Hey there, boys and girls. So today the part of the experiment is our day 2. We're going to look at some of the results and the progress that we've made, and then maybe look at some of the data, or at least start plugging in some data. So the materials that I'm just using today is I'm using a measuring tape, I'm using a spoon, and then I'm using a bowl for being able to measure these out on. And I'm going to take a look at each one of these, but if we look here first, we got our H2O gummy bears. You can already see, isn't that fantastic? Look how big those guys are. They're thick. No, they're huge. Look at those guys. So I'm going to definitely take one of these out and kind of show you what that looks like. Alright, we're back. So there's a couple of things that we have to observe. So the water, the one that's just water, that one definitely grew in size. When we measured the first gummy bear, or when I measured the first gummy bear, it was 2 centimeters by 3 centimeters large. And now it is 4 to 5 centimeters large, which is pretty significant. So that definitely grew in size. The biggest one, though, is the Coca-Cola, which is kind of surprising. I'm surprised that the size on that one increased, but that's 5 centimeters to 3 centimeters in length, and that's pretty thick. The red one did shrink, and the red one was the salt. So those people that said that salt definitely draws out, it's also a lot harder than the other two. It's absorbing a lot more of that salt. So very interesting. And then the one with sugar is basically the same size as the one with just water. So very interesting indeed. We're going to keep looking at those and keep checking them out. But I just wanted to show you each one of these. Now, this was an orange gummy bear. Can you believe that? That was an orange gummy bear, and now it's completely brown. It completely absorbed the Coke. I'm not going to taste it yet. I'm going to wait until the last day, but that is quite interesting. So thank you very much, ladies and gentlemen, for watching, and we're going to put the data into our data tables just so we have it for day 1. Thanks again. Well, hello there, students. So just to check in, on Monday, the day of the experiment, we were looking at size, texture, and form in terms of our data. We were looking at each individual one. Now, I'm doing this just for the H2O track. However, we're going to kind of keep track of each one of these different solutions and the gummy bears and their reactions to them. If we look at the size for the H2O, and this is just H2O, if we look at the size, we have 2 centimeters by 3 centimeters on Monday. We grew an entire centimeter on both length and width, total of 3 centimeters by 4 centimeters now, thanks to just being submerged in water for about 24 hours. The texture started yesterday at being pretty firm. I mean, you know how gummy bears feel. While they're pretty firm and pretty hard, they're not the hardest substance out there, but now they're so squishy that you can literally make them break with just holding them. And then the form was intact before. It was a gelatin, and now it's starting to dissolve. And we're going to keep track of this and kind of analyze this data. But from what we can tell now, what do you think are some of the things that are happening here? Think about water and its effect on an object. What is it that's happening? I know some of you have described the size and the texture as being unique for each one of these. Something also to mention, the salt. It is much smaller, the gummy bear that was submerged in salt solution. It's much smaller now, and it's a lot harder too. So why do you think that is? Maybe you can think of some comments for that. But this experiment is really showing us a unique property of water, which is different than other properties of water. You know, water is a really fascinating substance on this earth, and it has so many properties. And this is just one, and it's called osmosis. And I want you to take some time and maybe see if you can find the definition of what osmosis means, and then maybe put it in your own words, or at least come up with an idea of where you've seen that out there in the real world, or at least in your lifetime. You know, I was talking with a friend of mine who has seen many different cooking shows, and one of the ways that he sees this type of osmosis is actually the opposite when he's cooking spinach. And spinach is a leafy green, but when you cook spinach, you put a bunch of spinach into a pot, and then you kind of let that simmer, and you put it in water, and you kind of allow the water to evaporate and burn off, and it actually gets a lot smaller. It's quite interesting how that works out. So this is kind of what I'm talking about. If you look at the spinach itself, so we're letting it simmer and putting it over a little bit of water, and you just watch it cook. And after a while, you'll notice that the spinach, she's still able to add more in. It starts to shrink, and it continues to shrink more and more. And this is kind of the opposite effect of that osmosis piece, where instead of the water being absorbed into, it's instead being taken out of. Just fascinating.